Let's find the antiderivative of 2x cubed plus 3x. The first thing we're going to do here is keep the 2 out front, and then times x, raise the power of 3 to 4, and then divide by 4. Then this will be plus 3 times x squared over 2. Just to simplify and make things a little nicer, that'll cancel the 1/2, so we have x to the 4th over 2 plus 3 over 2 x squared plus c. Now we're going to introduce a term called an integral. An integral has this like curvy S sort of symbol like this. And basically what this right here is saying is the integral of the function f of x, and this dx basically means with respect to x. You're integrating it for the variable x. Right now, for our purposes, it's not going to be largely that very important, and you can generally kind of ignore it. But basically what an integral means is you take the antiderivative. So right here, f of x plus c. That's essentially what this symbol means. Now, here's where it becomes really important. Now, remember when we started with a position formula and we went to the velocity by taking a derivative? And then, if you took the derivative of the velocity, you would get the acceleration. Well, the integral works in the opposite direction, since it is, of course, the antiderivative. So if you take the integral of the acceleration, you'll get the velocity. If you take the integral of the velocity, you'll get the position. And if you take the integral of the position, well, we'll talk about that tomorrow. Don't worry about it. It's cool. This problem includes students dropping an egg from 30 feet. And they know that the instantaneous velocity function is negative 32t, where our t is the time in seconds. So, if it's the velocity, we're asked to find the position function. So what we need to do is take the integral of the velocity. So we're basically taking the integral of negative 32t with respect to t. So that's going to equal the antiderivative, which we have negative 32. Then we have t squared, we raise the power, divide by 2, plus c. This is where it's going to be important, I swear. It was going to come up, I knew it. So if you do this, it becomes negative 16t squared plus c. Now, we can figure out what this c is in this case. Notice that it's a 30-foot drop, which means it's at 30 feet when the time is 0, because it starts at 30 feet. So, what we can do here, we know that this should equal 30 when t is 0. Alright, some real quick solving here. All this time 0 crap goes, bye. So, c is 30 in our case. So the position function, s of t they're calling it, is negative 16 t squared plus 30. The bottom part is asking how long will it take for the egg to hit the ground. Essentially what we're looking at there is when is the position function 0. So I'm going to take the position function, negative 16 t squared plus 30, and set it equal to 0. If you subtract 30 from both sides, you get negative 16 t squared equals negative 30. Divide by negative 16, we'll get that t squared equals 1.875. And if you take the square root of that, you'll get that t is roughly 1.37 seconds. And that's how long it will take for the egg to hit the ground.